right? And so the context changes depending on which local branch you're on. Git pull will act differently. You can't explicitly say like git pull origin space master to make it very explicit that you want to fetch from origin and then merge into master branch, into whatever branch you're currently in. So if you want to do them separately, that's how I do it. If you want to run git pull, you can say git pull instead and it'll do the automatic merge. The nice thing about fetch is that it does not modify your working directory. If you have uncommitted changes and you want to just synchronize with the server before going offline, then you can just run git fetch. It will not change or screw up anything that you have going, right? You can have you can have a bunch of staged changes and unstaged changes and stuff. You just run git fetch. It just updates your database and all your bookmarks, and then you can finish your stuff and then merge in from the remote stuff later, right? So that's why I like doing fetch instead of pull. Also, when you run fetch, it'll show you all the new branches that the server has. Whereas pull will do that, but then it immediately merge, and so you kind of lose it in the output, because then you see all the merge output last rather than the fetch output. Anyways, so I prefer to do them separately, but you can certainly run git pull. Okay, so since this is sort of an important concept, I want to show you sort of the same thing, but now with multiple developers in a distributed environment. So now in this scenario, this is more of an open source scenario. So everyone in this scenario has their own, nobody has write access to anybody else's repository, right? In the previous one, everybody's working off one central repository. In this one, nobody has write access to anybody else's. Okay, so this is how a lot of open source projects work. So let's say that I have a master branch. I have 2 files and I've done 1 commit. So I'm going to have 4 objects. I'm going to have a commit that has the metadata, the tree that's the directory listing, and then the 2 blobs, the 2 file contents. Right? So those are the actual 4 objects I'm going to have. Now, if I run, there's a command called git remote where you can run, you can say I want to add new aliases. So if I set up some GitHub repository and I want to add that as a remote, I can say git remote add public, and then the URL that GitHub gives me, the SSH one that I can push to. And now I have public. Now I can say git push public or git push public master. And that'll take all my objects, put it on my server, and remind me where the master branch of my public server is. Now, people want to help you with that. So Nick clones it, and whatever URL I give them for that project, he clones it, and now that's his origin. It's my public, it's his origin. Doesn't really matter. The URL is the same thing when it's unaliased. And he modifies 1 file, right? So he clones it, modifies 1 file, and commits. Now he has a new file content, a new directory listing, and a new commit. So he adds 3 new objects. Jessica does the same thing. She clones the thing down. She changes both the files. So now she has 2 new pieces of content, a new directory listing, and a new commit. Okay, is that clear? Now, instead of me having to give them write access to contribute to my project, or me having to take patches on a mailing list, what they can do is they can just say, I have all of the objects of this project. I don't need to write to yours. I can create my own project on the internet, push my stuff, my new stuff to that, and then just send you the URL, right? The read-only URL for that. So we all have one write URL, and then everybody else's read URLs of all the contributors in the project. Now I can add, Nick sends me an email that says, here's a read-only URL for my project. I've fixed, bug 15 or something, right? So I can say, cool, I've wanted to have that fixed for a while. I'm going to add you as a remote. So git remote add some nickname, right, some alias. So I'm going to call this one Nick, so I don't have to write out that whole URL every time. And then whatever the URL is. Just says, I fixed feature B. And gives me the read-only URL for that. So I say, okay, I want to add you as Jess now, and I'm going to put in that URL so I don't have to write it out every time. Now I can say git fetch Nick, pulls down just the difference, and gives me a master branch on the Nick server. And again, my master branch and my working directory don't change. And I can say git fetch Jess, and pull down just the stuff Jess has, and give me her pointer to her master branch. And again, nothing of mine has changed, right? So I just have that new in my database. So what's interesting here is I know of 3 different remote servers. I know where the master branches on all 3 of them are, and I know where my own master branch is, right? Now, if I merge them together, if I can say git merge Nick/master Jess/master, that will merge both of those features in simultaneously. You can actually merge as many branches as you want in one go. It's not limited to just one. You can say I want to merge these 8 branches together into one new mega ultra awesome commit. And it has been done. The Linux kernel, I think, has like a 12-way merge in it at some point. But why? So in this case, what it's actually going to do is a fast forward on one and then merge the other one in. But anyways, so it merges them together. I get some new objects, and then I push, and that's going to, see how many objects are in mine right now? There's 4. I push, everything that's changed goes up, right? So now, get push public, or get push public master, or whatever. It goes up to mine. Now, what's interesting about this is that here's where Nick's objects have proliferated, right? Here's where Jessica's specific objects, her feature fix is proliferated, and here's where my merge of the two have, right? So now, Nick fetches from me the only URL that he knows the 2, right? He has a read-only from the main project and a write of his personal one. And Jess has the same thing. Now, if Nick fetches from me, he will get my merge, but he'll also get her changes, right? So Nick is collaborating with Jessica even though he doesn't know that she exists, right? He doesn't know this URL necessarily. He just knows mine. If I merged in for 12 other people, he'd get all of their work and nobody has to have a write access to my repository. Everyone is still collaborating together, and it's not difficult to do. Okay, so it's one of the cool things about having this distributed system. Are there any questions?
So knowing the history of that, let's just say who made those changes.
Yes, every commit object has the person that wrote it originally.
So Nick could see through what he pulled in.
Yeah. That he can say what is in, once he pulls this down, he can say what's in this that I don't already have in my master branch, and it'll show him my merge and her commit.
Yeah.
Yeah. So he can see that he wrote something and I merged it in, so he can trust that as I merged it, right? Yeah.
So does it just work if Nick tries to fetch from Jessica's, because he's already got those changes from the
Yes.
other one?
If he knows about Jessica's, if he finds out her URL somehow, and he adds that as a remote and fetches, it'll just take those 4 she has, add it to his the same way as mine was before my merge, right? And then if he fetches from me, that'll just complete the loop. It'll just bring down the 2 he didn't have already.
Okay.
But he'll have the pointer to where hers is last, and where my merge is, and where his last is master. So his pointers might be in different places. It depends on when he fetched, right?
Right, sure.
Yeah. Yeah.
What's the command to see the difference between after a fetch?
This next. Okay. Was there a thing?
When you do a merge, does it necessarily commit the snapshot with all the conflicts in it?
No, it does not. When you do a merge and it has conflicts, it will stop before writing the snapshot.
Right.
So it stops with your index in a modified state, and you have to run git add once you fix them. It puts in subversion style merge conflict markers. You fix it, you run git add to restage everything, and when it's done, you run git commit to finalize the merge.
That snapshot will start the right parents.
The snapshot will what?
Have the correct parents listed.
Mm-hmm. Yeah. And it also does the same. When you do a merge, and it has to write a new commit, so you do fast forward, it doesn't write anything new, right? If you do a non-fast forward, it'll write a new commit. It auto-generates the message for you. When you have a conflict and you fix it, and you run git commit, it will pre-populate it with the auto-generated thing, but you can also add in, like, this is what I did to resolve this conflict. And then, if you run git show, so git show is a way of sort of inspecting the database. You can give git show any of these shows, and it'll tell you if it'll just give you the content, or it'll give you the directory listing, or it'll give you the commit metadata. If you give it a merge commit that had a conflict, it will figure out that it had a conflict, and then show you left, right, and then how it was fixed by the person that did it. And only the conflicts, not all of the changes in the merge. So you can, if you have something that was a merge with a merge conflict, you can say git show on it to see how it was resolved, in case that resolution was done badly. And you can blame that person, which is what it's all about. Okay, so differences. So now, which is probably the last thing I'm going to get to, unfortunately, I thought I was going to have more time, or I thought I was going to talk faster, which I'm sure you all would have loved. Now it is looking around. So now I want to see the differences between my branches, right? Because I can have 100 branches. I can literally, if I show you some of the dumb projects that I have, you can see just tons and tons of branches, right? So how do you see the differences between those branches? Which ones you need to pay attention to? If you fetch from something and something new came down, what's in it that you don't already have? And if you merge it in, what would it change? Would there possibly be merge problems? So The way that you answer all of these questions, and many more, is with a command called get log. And get log generally will do the same thing that svn log will do, which is show you the commits that have led up to that point. But it does it a little bit differently. It walks your commit history. So you can give it any starting point, and it will just walk the parents, anything it can reach, and it will list out all the commits that are reachable from that starting point, right? So if this is what your history looked like before you merged in IETN again, right? So you have one commit on IETN that is not in master, and you were on this branch and you just ran get log with nothing. It's going to assume get log head. It's going to assume I want to see the history of everything from the last commit on the branch I'm currently on. And so what it's going to do is it's going to follow that to the first commit that points to, and then follow the parents and follow those parents and so on and so forth, and find everything that's reachable from that commit, everything that conspired to create this snapshot eventually. Right? All of these commits had some change in it that eventually made its way into that or changed it somehow. So these are all the ones that are important to us from a master standpoint. This one did not modify the snapshot, so we don't care about it. Right? So it will list them all out like this, starting from the first one. So I don't know if you can see, but that's the first one. It's going to be the first one that's listed on the thing. That's the last commit you have. And there's a couple of interesting things. One is you can see 1675, right, so that matches this here. And it shows you that it's a merge commit, right? The merge commits will be marked slightly differently in the log output. It'll say this was a merge of these two. So you can see which ones are merge commits. You can also say get log dash dash merges. I think it'll just show you the merge commits, or dash dash no merges will strip them out if you don't care. You just want to see the ones that introduce work. So this shows, right, left side, or the first parent, the one you were on, the one you merged in, and then after that it just walks them down and it puts it in a flattened list. So here's one side, that commit and that commit. Here's the other side, that commit and that commit, and I'll show you the other one after that. It'll automatically page it for you. But it just shows you the whole thing, just starting from wherever head is. Now, for each one, it shows you the full 40-character SHA, which the nice thing about the SHA is that if you remember back, if you change content in one of the files somewhere in the history, right, and try to pretend like that was originally like that when you did the commit, what's going to happen is you change the content of the file, it will change the SHA. That changes the SHA that it points to in the tree, right? Because you're changing the content, so then the tree content changes, which changes the SHA of the tree, which changes the SHA in the commit that has the point to that tree, which changes the SHA of the commit itself, which changes the SHA of anything trying to point to it. So you can't modify anything in the history view without modifying every commit upstream from that, right? Everything. So you can't go back and change this, a file in this, or a commit message in this without changing this one and this one. Because everything points to stuff behind it. So it's a cryptographically signed, it's a signed system, right? So the nice thing about this is that this encapsulates not only the snapshot of that commit, but all of its history, right? All of the merges, every commit that came before it is in that SHA. So if you send that to somebody, right, even if the snapshots look similar, or the message looks identical, or the author and time and stuff, if the commits are not identical, it's not the same commit. Something is different about it, right? Even if it looks the same. So, and that will be the same on everyone's system. So if you QA, if you have a QA department or something, and they QA some commit, and say this commit is good, they should send the SHA, not the tag or the branch name, right? Because that could have changed somehow subtly that's hard to tell. If they send a SHA, you can verify you have it in your system, that it wasn't rebased, that it was modified in some way, that content wasn't changed. You can tell Git to verify it and make sure that all of its history is exactly checksums the same still on your system, and that's what goes out into production. So that's one of the nice things about the SHA system. Now, so it gives you the SHA, gives you the author as they identified themselves when they ran the commit, the date they did that, and then the message that they added. Okay, so now there's a couple different things you can do. One is you can do -- one line, which gives you that same history in one line per commit. So this is a much easier way of looking at large